Now we're going to complete a table of basic differentiation rules that we should all know. First, we start with f of x being a constant function. So when f of x is equal to a constant c, then the derivative f prime of x is equal to 0. Next, we have the power rule. If f of x is a monomial, so of the form x to the n, then the derivative is obtained by n times x to the n minus 1. This means you lower down the exponent n and then you decrease it by 1. As an example, if f of x is x to the fifth, then f prime of x is obtained by lowering down the exponent 5 and then times x to the 5 minus 1, which means 5x to the fourth. As another example, if f of x is equal to x to the 3 over 2, then f prime of x will be equal to 3 over 2 times x to the 3 over 2 minus 1, which means 3 over 2 times x to the 1/2. Another example, if your f of x is 1 over x cubed, then we can write this as a power function, x to minus 3, so the same differentiation rule applies. I lower down the exponent, negative 3, and then I decrease by 1. And I obtain negative 3 times x to the minus 4. Okay, so these are some examples of how the power rule works. Now we move on to other derivative formulas. So next, we have f of x equals sine of x. Then the derivative is equal to cosine of x. On the other hand, if your function is cosine of x, then its derivative will be given by negative sign. Next, we move on to exponentials and logarithms. So if your function is the exponential with base e to the x, then its derivative is the simplest possible. It's the same, equal to e to the x. This is the main reason why the Neper number e is so used in calculus, because the derivative of e to the x is equal to itself. Also, if you have natural log of x, then its derivative will be given by 1 over x. So these are some basic differentiation rules that we are gonna learn today. And now, how does the derivative operation behave with respect to regular operations? For example, if I am taking the derivative of the sum of two functions, so f of x plus g of x prime, then this is equal to the sum of the derivatives. The same thing happens for the difference. If you take the derivative of the difference, this is going to be equal to the difference of the derivatives. If you have a constant times a function, then its derivative is the same as the constant times the derivative of the function. So these are the basic ones. Now on to more complicated formulas. For the product, it's not as simple as taking the product of the derivatives, but there's a special rule called the product rule. This is telling you that the derivative is obtained by doing f prime of x times g of x plus f of x times g prime of x. And finally, the most complicated one, the quotient rule. Here again, it's not as simple as just taking the quotient of the derivatives, but there's a special rule. So you're going to have f prime of x times g of x minus f of x times g prime of x, everything divided by g of x squared. And tomorrow we're going to apply these formulas in some practical examples. In the next videos, I'm going to show you the proof of some of these facts using the definition of the derivative. In other words, why do these formulas hold? Watch the next videos to know.